Hello everyone, in this video we're going to learn about insertion and deletion operations in single linked lists. So here's an example of a linked list. As you see, there are four nodes A, B, C, and D. And let's say we're going to insert a node between the node B and C, and we're going to see that how this is going to happen. So because it's a single linked list, that means that we don't have access to the previous nodes. Every node only knows its next node, and the first node will be called the header. And here in this example, we're not we're not labeling the last node to be tail. So let's see that how we can write the insertion method, and I will use the code like the some pseudocode very close to the Java code for implementing the insertion and also deletion methods. So I'm starting with the method signature, which gonna be let's say, and we can ignore these parts that if it's a public or protected or another method scope. So we have the insert method, and let's say that the data we're gonna insert is from the type T, and let's call it, for example, data. So here is our data that we're going to insert, and again, as I said, there's going to be a node between B and C. First of all, we're gonna create a node. So a node will be created. Again, it's going to be from the type T to make it again generic. Let's call it, for example, node N, and it's going to be a new node. We're assuming that the constructor exists, and again, I'm not too much worried about these details here. Just create a node with that data. Okay, so here is our node. So I'm going to put it here. So this is node N, and here is our data or data that has been stored in the node N. So here, assume that this node N with this data is between B and C, but actually in real application, or when you want to like to implement it in full details, you need to find the proper location of the node N. So for example, if your linked list is sorted, and that means that A is less than B and C and then D, then you need to make sure that the data also is greater than B and less than C. In other words, we should have A less than B, less than data, and then less than C and less than D. So finding the proper location of the data is important, and for that you can actually write the search like the method to search an item, and we're find out where should be the proper location of that node that you're going to insert. So here, let's see that how we can actually insert this node N between node B and C. As you see, there exists a connection. I'm going to call this connection 1 that needs to be broken, and we also need to create two new connections. This new connection here from B to N, which I'm going to call the connection 2, and there's a connection from the node N to C, which I'm going to call the connection number 3. So and for sure I cannot just delete or remove the connections from B to C without making the connections like at least connection number 3. Otherwise, I'm going to lose the connections from B to the rest of the linked list. So what I'm going to do here, I'm going to just write that, as you see here, let's create the third connection first before removing or deleting the first connection. So I'm going to write n.next, and again, I'm not worried about the details of implementation. So you can call a setter method. So n.next can be the node C. Okay, the node C, and here we create the third connection here, and then now I can just write b dot next is the node n. So, and that is the 2. And this one automatically deletes or remove the connection 1 because we just said that the next one node of the node B is something else, as not C anymore. So this somehow will take care of the connection 1 as well. So as you see, this will go away, and then that's how our linked list would look like after adding the node n. So here again, I skip that part that finds the node C and the node n. So if we want to maybe write in more details, first we need to find and search for the node C and n. So I'm going to write the code that finds the proper location of this node n. So in other words, the node C and then the node B needs to be found maybe with the search method. So maybe here we need to add the search. So here B, okay, so the node B will be maybe find, and also we're passing the data again. So that's gonna return the node that this node like the n will be inserted. Also instead of C, maybe also we can write maybe b dot next. Maybe that's even better. So I just wanted to show you that how what are the node B and C and how we actually write the C. So C is nothing rather than b dot next. As you see, it is before removing the connection 1, so it's fine. And then here, after writing b dot next equal to n, we're removing connection 1, and everything is will be accurate. So let's see that how we can write the find method. So we're writing the method find, and we're passing the data again, and we're going to see where these data must be inserted. And we're assuming here that the linked list is sorted. So the very first item is the smallest one, as you see here again, as I mentioned. A is less than B, and B is less than C, and C is less than D. So let's find, and again, we here, we are not worried about how we can actually compare these values A, B, and C, and D. It can be numeric values, they can be maybe some objects, but for sure there are some mechanism to compare these values, and I think you're all familiar with that. If not, you can just maybe, at least in Java, there are, you can implement interfaces that are used to do the comparison. Or in other language also, we can use the provided mechanism or libraries. So here is the find method, and I'm going to see where these data must be inserted. So I'm starting with the very first node, which is the header. So I'm going to put in the temporary node, and then I'm going to traverse the linked list to find a proper location of data. So here I'm starting with the current node, or the temporary node, maybe, whatever is called. So current is equal to head. And then here I'm going to write a while loop. So this while loop will go while that current is not equal to null, and I want to make sure that I not reach the end of the linked list, and also while the data of the current is greater or less than this data that I have here. Okay, so because each node has some data. So while this is the case, means that first of all, I have not reached the end of the linked list, and also it says that the node that I'm checking, for example, the value of A must be less than the data that I see here. So, and here when I say current.data, it can be A, it can be B, and C, and D, depending on what is the current node. So while this is the case, I'm going to just write current be equal to current dot next. So it just traverses the next node and it updates the next node. So either I have reached the end of the linked list, or I found a node that doesn't have the data that is less than the data that I have here. For example, the node C. So because the node C doesn't have the smaller data compared to the node N, that means that the node C is the one that I need to insert the node before that. So as you see here, because it is a single linked list, I also need to keep the node B. So what I'm gonna do, I'm gonna keep or define another node, so which is like the previous, and I'm gonna put it to null. And before updating the current to the current next, I'm gonna just write previous to be equal to current. And at the end, when the while loop is done, what I'm going to do, I'm going to say return the previous one. So let's test and see if it works properly or not. So for this example that I have here, the first node is A, and we're assuming again the data of the node N is greater than B but is less than C. So current is head, and then previous is equal to null, while current is not equal to null, which is not, and current.data is less than data, which is correct. It put the previous to be current, which means that previous will be the node A or just the header. And then the current will be the node B. So it goes to the while loop again, and so we're gonna update again the previous to be B, and it's gonna update the current to be C. So it goes here because current is not equal to null, is not, and current data is not less than data, because as you see here, C has greater the value than data. So it's going to stop and it's going to return previous, which is the node B, and that's exactly what I need here. So in this line that I have had it. So as you see, to insert a new node, first of all, you need to find the proper location of the node, and then you can just break some existing connections and add new connections. So in the single linked list, when we have only one connection from one node to another one, and there's no previous one, you need to break one connection and you need to add two new connections. So it is very similar to write the code for the deletion. So as you see here, let's say that for example, we're going to delete the node C, and which means that we're going to break two connections, which is from the B to C and also from C to D, and instead we're going to make a new connection from B to D. So I'm going to create a new example here. So, and I'm going to show how the deletion works. So here is the linked list, the single linked list. Again, I have the nodes A, B, and C, and D, and A also is called the header node. And let's say that we're going to delete the node C, which means that we're going to break these two connections here. So I'm going to call this one connection 1, and I'm going to call this connection 2, and that means that I need to create a new connection from B to D, which I'm going to call it connection number 3. So similar to what I wrote for finding the proper location of a new node, also I need to find the node C. Or in other words, also I need to find the node B here, because that's where it needs to have a new connection to node D. So I'm going to write the delete method. Again, we're assuming that we're going to delete the data, okay, which is in this case data, where data is equal to the node C, or this is the data of the node C. So again, we need to find the node C, okay, or the B. So we're calling the data, find with the data, and it's gonna for sure find the node B, because B, we know that was less than C. And as you know, in the find method that we wrote, it returns the node that has less value compared to the node or the value that we just passed. So it's gonna find the node B, and now what we need to do, we need to remove the connections 1 and 2, and we need to create the like the connection 3. So here, the node C, also we know that this is the data of, or the B dot next is C, so I can simply write C is equal to B dot next. Again, that's a node that I'm going to delete. So here it is in here, and then I can write B dot next to be equal to C dot next, which is, we know that is the node D. So I'm going to just write here the node D. Okay, now what I have done here, by this statement here, I actually done this number, connection number 1, remove number 1, and created the connection number 3. So here, this one is deleted, and also have created this connection like the 3 here. So, and at least in Java, because I will automatically take care of like the node C, because node C is not accessible anymore. So the node C will be will be removed, and I don't need to be worried about it. But in some other languages such as C, maybe you want to like to delete like the node C manually to make sure that we don't have like the reference issues. So here the node, although the node, the connection number 2 exists, but again, we don't need to be worried about that, because the node B is not connected to the node D directly, and we can say that this is actually done. So these are the two methods, insertion and deletion in a single linked list. Again, the actual implementation might be a little different, but I just wanted to show the concept of inserting a new node between two nodes, and also deleting an existing node, and see that how the connections will change after or before these operations. In my next videos, I'm gonna also talk about the double linked list and the pushback, push front, pop back, and pop front, and insertion and deletion operations. So before ending this video, also I'm going to talk about the time complexity of these two operations. As you see in the insertion, we need to find the proper location of the node N that we're going to insert, and as you see, it needs that we call a function which is called find. So if going back to the function find or method find, we see that we have a while loop that it depends on the size of the linked list, that how many times in general it's going to traverse the linked list. So if the item we're going to insert is somehow is the largest item, we need to traverse the whole linked list, which means that we need to do n operations. If it is the smallest item, we only need to do maybe one search or one operation, or just a few small operations. But we can see that in general, or in average, the insert operation is from the big O of n. So same thing for the delete operation, because again, we need to find the proper data. It can be maybe the last item, or it can be the first item, or it can be maybe some items at the middle of the linked list. Again, in the average, we can see that it is from the big O of n. So both insertion and deletion in a single linked list, in average, have the time complexity of big O of n, and both of them have the big O of 1 as the best cases. So average cases big O of n, and best cases big O of 1.